What if a robot could move almost like a human hand? And we are closer than ever. In the middle of a crowd, something caught everyone's attention. Optimus 3 stood there, and just behind it was Optimus 2.5. After months of silence, we finally have a clearer look at Optimus 3, and it looks very different. Elon Musk once said this version would feel like a human inside a robot suit, and now that idea feels much more real. One of the biggest reasons is the hand. A recent video of Optimus 3's hand made people stop and look twice, because it doesn't look like a simple machine anymore. It looks like a human hand covered in a tight glove, almost natural, almost alive. Some early details also show something important. Optimus 3 is already far ahead of version 2.5 in design progress. Even though it is fully covered in black, almost like a sci-fi Terminator-style body, that design choice may actually be intentional. Not for looks, but for production. Because in robotics, appearance is not the goal. Mass production is. If a design is easier to build at scale, it wins. Now compare the two versions closely. Optimus 2.5 still looks like a prototype. You can see exposed metal parts, gold and black surfaces, visible joints and mechanical gaps. It looks powerful, but still unfinished. Even the head shows this. There is a bright light-style visor, and some internal parts are still slightly visible. It looks advanced, but not something you would place in a home or around people comfortably. Now look at Optimus 3. The design changes completely. It is smooth, fully covered, and much more minimal, almost like a full-body suit hiding everything inside. The joints are no longer exposed. The shoulders and hips look rounded and softer. The whole shape feels more natural, less machine, more human-like, and likely safer around people. Elon has already said something important before. Building Optimus for mass production is extremely hard, so Tesla had to change the design completely, not just to make it better, but to make it buildable at scale. He even hinted that earlier versions were not practical for manufacturing. In simple terms, Optimus 2 was too complex to mass produce efficiently, so Optimus 3 became a full redesign, a shift from prototype thinking to real product thinking. And there is more. Elon recently compared Optimus 3 to one of SpaceX's most advanced creations, Raptor 3, a rocket engine known for extreme efficiency and simplified engineering. That comparison is not casual. It suggests Optimus 3 is being treated as a major engineering breakthrough. And in the background of the recent images, there is another small detail. Tesla employees wearing winter sweaters, which suggests this scene was likely captured in December, meaning the Optimus 3 design may have already been completed months ago. Elon also mentioned earlier that the design was nearly finished, and that it would have human-level hand dexterity, a hand capable of very precise movement, not just gripping objects, but handling delicate tasks. But now a big question remains. If Optimus 3 is this advanced, why hasn't it been fully revealed yet? Tesla promised progress early this year, but the official launch is still missing. And that brings us to something even more interesting. The hand itself may be the biggest clue, because it is no longer a simple robotic tool. It is becoming something much closer to human structure. And now something even more interesting is happening. Optimus 3 is not just improving, it is slowly crossing a line between a machine and something that feels almost biological, especially in the hands. But why is that such a big deal? Because in humanoid robots, the hand is the real test. Not walking, not balance, the hand. A robot can walk and look impressive,
It can even stand on a stage and perform tasks. But if its hands can only grab simple objects, then it is still just a demonstration, not a real helper. But when the hand becomes advanced enough, everything changes. The robot can start doing real-world tasks, not just showing skills, but actually helping in daily life. Elon Musk has talked about this vision clearly. He once said Optimus could help with real human needs, things like taking care of children, walking pets, or helping elderly parents at home. And this connects to a much bigger problem in society, an aging population. People are living longer than ever, but life is also getting more stressful. Work is demanding, time is limited, and families are not always able to be physically present. As a result, many elderly people end up alone, even when they are deeply loved. They may not get the daily support they need or the feeling of constant safety. This is where Optimus becomes more than just a machine. In Elon Musk's vision, it could support elder care, not just physically, but emotionally too. It could remind people to take medication, help prevent falls, and respond in emergencies. But also something more subtle. It could offer companionship, simple conversation, and a sense of presence. Now, behind all of this intelligence is something very important: the brain of Optimus Gen 3. And surprisingly, it's not built from scratch for robots. It's based on Tesla's driving AI system, the same technology used in Tesla's self-driving cars. Tesla has confirmed that Optimus will use advanced AI chips, starting with AI 5, and future versions may move to AI 6, possibly in next-generation robots beyond Gen 3. With this system, Optimus can do more than just follow instructions. It can understand space in 3D, recognize thousands of objects, and react almost instantly. But Tesla is not using old-style programming anymore. Instead of fixed commands, it's moving towards learning-based intelligence. In simple terms, Optimus is designed more like a learner than a machine. It watches humans, learns from video, and improves over time, almost like a child learning how the world works. But intelligence is not enough. There is another major challenge: energy. Because a humanoid robot is not like a car, it doesn't just move forward. It constantly uses many small motors at the same time, in arms, in legs, in hands, all working together. Think of it like running with a heavy backpack. The more weight you carry, the faster you get tired. Robots face the same problem. A bigger battery gives more power, but it also adds weight, and more weight means more energy needed just to move. This creates a very complex balance problem: power versus weight versus efficiency, and it's extremely hard to optimize. To solve this, Tesla is taking a different approach. Instead of cheaper battery types used in many systems, they're reportedly using higher density NMC batteries, developed with LG Energy Solution. These batteries store more energy in less space, which is very important for a humanoid robot, because every gram matters. According to reports, Optimus Gen 3 may have around 3 kilowatt-hours of battery capacity, up from about 2.3 kilowatt-hours in the previous version. This could allow around 7 hours of operation, depending on workload and movement. And long-term, Elon has even a bigger vision: a robot that can work almost continuously, like a non-stop assistant, always available when needed. But behind the scenes, there is another major factor: manufacturing.
Even though Tesla assembles Optimus in the United States, a large part of its supply chain comes from China. Reports suggest that more than half of the components, around 50 to 63%, come from Chinese suppliers. And this is not just about cost. It is about scale and manufacturing speed. Analysts have warned that if Tesla avoided Chinese suppliers, the cost of each unit could rise dramatically, from around $46,000 to over $130,000. But Tesla's long-term goal is very different.
They want to bring the price down near $20,000, close to the price of a basic car. And that level of pricing is only possible with a global supply chain, highly optimized and extremely efficient. This is why a full Optimus ecosystem is starting to form. Companies around the world are contributing parts, thermal systems, sensors, and precision components. China, in particular, remains a key player in this space because of its large-scale precision manufacturing strength. At the same time, competition is already rising. Some companies are building humanoid robots at much lower prices, but often with limited strength or durability. And that brings us to the biggest question. Can Tesla actually deliver Optimus at scale? Elon Musk has made one thing very clear. Safety is not optional, it is the priority. He believes Optimus must have strict hardware-level limits so the AI cannot act freely without control. That means built-in safety systems, constant monitoring, and backup protections for every action. Before Optimus is ever released, it must prove it can run safely for thousands or even millions of hours without major failure. Then comes another huge challenge: manufacturing. Building one robot is hard, but building millions is a completely different problem. To make Optimus affordable, Tesla needs mass production at massive scale, with consistent quality and low cost. He has spoken about producing millions of units per year, but that would require rebuilding supply chains almost completely, especially for critical parts like actuators, sensors, and movement systems. And here's the risk. If even one component fails in supply, everything slows down, costs rise, and timelines slip. But there's still another challenge, and it may be the most important one: human acceptance. Because even if the technology works, people still have to trust it. Letting a robot into your home is a big emotional step. People will ask, is it safe? Is it helpful? Can I trust it around my family? And on top of that, there are real concerns: job loss, privacy, and how much control AI should really have. These fears cannot be ignored. They must be solved through design and strong safety systems. When you zoom out, what Tesla is trying to do with Optimus is extremely ambitious, but not impossible. Tesla has key advantages: large-scale manufacturing experience, strong AI development, and tight control over its supply chain. But there's still a big gap between a working prototype and a product ready for millions of homes. If Tesla can solve engineering, safety, manufacturing, and trust, Optimus could become one of the most important inventions of this century. But if even one part fails, the timeline could shift, maybe by years. Either way, Optimus is pushing robotics out of labs and into the real world. It's risky, but also deeply transformative. And right now, this future is no longer just an idea. It's slowly becoming something real. Because of Tesla's progress in AI and energy systems, Optimus Gen 3 is starting to feel less like science fiction and more like something that could soon exist beside us in daily life. Now the question is yours. Do you think robots like Optimus will become part of everyday life within the next decade? And what matters more to you, lower cost or higher capability? Drop your thoughts in the comments. Optimus Gen 3 is still on the horizon, but it's already changing what we believe robots can do. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you don't miss what's coming next. See you in the next one. Goodbye.